Hello, and welcome to Getting Started with AWS IoT Greengrass, Nucleus Lite. My name is Greg Breen, and I'm an IoT Specialist Solutions Architect with AWS. In this video, I'm going to introduce you to Nucleus Lite, a new edge runtime for AWS IoT Greengrass. We'll build and install Nucleus Lite on a Raspberry Pi, deploy a custom component to it, and perform a deep technical teardown so that you can better understand how it works. So let's begin with an introduction to Nucleus Lite. This video assumes that you're already somewhat familiar with AWS IoT Greengrass. But to briefly recap, Greengrass is an edge runtime and cloud service that helps you build, deploy, and manage multi-process IoT applications at scale. Greengrass offers two edge runtime options, Nucleus and the new Nucleus Lite. If you're familiar with Systemd, one way to think about Greengrass Nucleus is that it's like a cloud-managed Systemd operating at scale. By contrast, Greengrass Nucleus Lite is a cloud-managed Systemd. Nucleus Lite is comprised of a set of daemons, each installed as a Systemd service, and each Greengrass component you deploy is also installed as a Systemd service. You'll see this in action later in the video. The key differentiator of Nucleus Lite is its smaller memory footprint. The original Greengrass Nucleus requires 96 megabytes of RAM, and because it's written in Java, your IoT device also needs a Java virtual machine, making a combined footprint of 150 megabytes. Therefore, your IoT device hardware would typically need total system RAM of at least 512 megabytes for you to be able to build your IoT applications. By contrast, Nucleus Lite has a footprint of just 5 megabytes and no dependency on the Java virtual machine. Consequently, you can build powerful IoT applications in constrained hardware with total system RAM in the order of 128 or 64 megabytes. Nucleus Lite therefore enables different use cases and a lower hardware price point. To achieve such a small memory footprint, Nucleus Lite implements only a subset of Greengrass features while still maintaining compatibility with key Greengrass functionality. The Greengrass cloud service can still be used for managing your devices in the familiar Greengrass way. Inter-process communication is supported for communicating between components. The core device role and token exchange service is supported for IAM credentials. Component recipes are compatible, meaning you can deploy a component to both Nucleus and Nucleus Lite. And AWS IoT Core connectivity is supported for your MQTT messaging. Let's go through some of the headline differences between Nucleus and Nucleus Lite. As you know, the RAM footprint is a significant difference. There's a similar improvement in storage requirements. Nucleus Lite is written in C instead of Java. Nucleus Lite only supports Linux and only those distributions that include Systemd. The directory structure of Nucleus Lite is more modular, making it somewhat easier to marshal it into embedded Linux distributions that need to support AB partitions for over-the-air update. Nucleus Lite uses static memory allocation, giving you greater determinism. Logging is done through the Systemd journal instead of custom text files. Configuration is held in an SQLite database instead of a transaction log. Nucleus Lite doesn't support Lambda functions. And Nucleus Lite only supports a subset of the Greengrass feature set. This subset will grow over time, but is unlikely to achieve full parity. There are various indications to help you choose between Nucleus and Nucleus Lite. Indications for Nucleus include the Windows operating system or Lambda function components, neither of which are supported by Nucleus Lite. You might be developing Docker container components or components written in scripted or interpreted languages. These will generally have a larger footprint and not be so conducive to constrained hardware. You might want to use a Greengrass feature that isn't supported by Nucleus Lite. or you might be composing an AWS IoT site-wise gateway, which is only possible with Nucleus. Indications for Nucleus Lite include, of course, that your hardware is constrained in terms of RAM or CPU clock. You might have compliance requirements that make Java unsuitable. You might be creating your own embedded Linux distribution with AB partitions, and the modular directory structure of Nucleus Lite could be appealing. Or you might be developing all of your components in compiled languages with a smaller memory footprint. These indications are not necessarily prescriptive. For example, if your hardware had sufficient resources, you could deploy Python components to Nucleus Lite. We'll in fact do this later in the video. So let's move on now to building and installing Nucleus Lite. The best way to get started is to go to the Greengrass console and select the Setup One Core Device wizard. From here, you can enter your thing name and your thing group name. Then you can choose between Nucleus and Nucleus Lite. In selecting Nucleus Lite, you're offered three options. The first two options use pre-built images for select devices and operating systems. We'll choose the third option, building from source, because it has the widest applicability. You can then use the wizard to create your thing, and to create and download your connection kit, which contains your device certificates and private key. When you create a thing, the wizard also creates your Greengrass role alias and corresponding core device role. And it also creates an IoT policy and attaches it to your certificate. Returning to the wizard, you can navigate to the Nucleus Lite source repository. All links are in the video description. The repository includes build instructions, as highlighted here, and also setup instructions, as highlighted here. We'll follow these instructions now to build Nucleus Lite from source and install it on a Raspberry Pi. Using an SSH session into my Raspberry Pi, we start by copying the connection kit from a thumb drive and extracting it to the /etc/greengrass directory. The kit includes a partial configuration YAML file that needs to be modified. Here I replace it with the desired configuration. If you've installed Greengrass Nucleus before, this file should look very familiar. Of particular interest is the root path setting, set here to /var/lib/greengrass. For Nucleus Lite, this defines where the Greengrass components are installed, but not where Nucleus Lite itself is installed. You'll learn more about this in a moment. Next, we use apt to install all of the build prerequisite packages. Nucleus Lite needs users and groups to run the Nucleus core and your components. In this step, I use the default usernames. The core user should own the /etc/greengrass directory that contains the connection kit credentials, and it should also own the root path directory /var/lib/greengrass. Now we clone the Nucleus Lite repository from GitHub and change into the directory. Nucleus Lite uses CMake to configure the build. Note that the install prefix is set to /usr. This defines where the Nucleus Lite binaries will be installed. The log level is debug, and I choose not to build tests or examples. We can proceed with configuring the build using these settings. With the build configured, we can now build Nucleus Lite. As mentioned earlier, Nucleus Lite is comprised of a collection of daemons, and the build process builds all of them. With the build completed, we can install Nucleus Lite. Everything installs to /usr, consistent with the CMake configuration. The Nucleus Lite daemon binaries are installed to /usr/bin, and the corresponding systemd service and socket unit files are installed to /usr/lib. Note that not all of the binaries installed to /usr/bin are daemons. There are also some utilities. Of particular interest is recipe runner, which you'll see in action later in the video. The repository also includes a script that you can use to install Nucleus Lite as active systemd services and sockets. Now we can check the running processes and confirm that the Nucleus Lite daemons are running. These daemons are managed under a systemd multi-target called Greengrass lite.target, and we can examine its status. Furthermore, we can list all of its dependencies, and you can see that all of the daemon services and sockets are running. If you want to understand the individual daemons in more detail, the repository includes design documentation as highlighted here. Returning to the Greengrass console, the Nucleus core device is online and healthy. Drilling down, the reported edge runtime is Nucleus Lite 2.0.2, confirming that we've successfully built and installed Nucleus Lite. Let's now deploy a custom component. Here's the recipe for our custom component. It has a configuration key called message with a default value of hello. It's also authorized to use Greengrass IPC to publish messages to an AWS IoT core topic. A critical part of the recipe is the new runtime key, which has been introduced with Nucleus Lite. If this key is absent, a component can only be deployed to Greengrass Nucleus. If this key is present, a value of star indicates that the component can be deployed to either Nucleus or Nucleus Lite. Examining the component source code, the component uses IPC to publish messages to AWS IoT Core. It publishes a message once every 10 seconds. The message includes an incrementing count, and the string in the message comes from the component configuration, which, as you may recall, has a default value of hello. Swapping to the console, you can see that I've already published version 1.0.0 of this component. It's a Linux component that supports both the Nucleus and the Nucleus Lite runtimes. Checking the public components, you can see that we have 3 that are compatible with Nucleus Lite at the time this video was made. These are Java components, so deploying them to Nucleus Lite would require you to reintroduce the Java virtual machine onto your device. Before we can deploy the component, we of course need to add the necessary S3 get object permissions to the core device role. We now create the deployment targeting the RPi Nucleus Lite thing group that we created earlier. Adding the YouTube demo component to the deployment, and also adding the Stream Manager component for the sake of comparison. We deploy and wait for it to complete successfully. Checking the core device status, it's healthy with both components running. Returning to our SSH session, if we list the Greengrass Lite target dependencies again, you can see that we now have 2 additional systemd services running, one for each component. In a few minutes, I'll show you how to inspect your component logs using journalctl. Listing the processes again, we can also confirm there's a process for each component. And finally, using the MQTT test client, we confirm that the YouTube demo is successfully publishing to AWS IoT Core as expected. Let's dive deep now by performing a teardown of Nucleus Lite. We start by using htop to inspect the memory consumption. Stream Manager, as a Java component, is the hungriest process on my device. Despite being a simple piece of code, my YouTube demo Python component is also relatively hungry. GG Deployment D is the hungriest of the Nucleus Lite daemons, with the token exchange service being the next hungriest. Scrolling down, the majority of the Nucleus Lite daemons consume very little memory. Inspecting the Greengrass Lite target, you can see that it's a systemd multi-target. We can list all of the Nucleus Lite daemon service and socket files. Let's drill into these by taking a look at the GG pub/sub daemon. It's part of the Greengrass Lite multi-target. The binary is stored in /user/bin. Systemd will restart the daemon if it exits unexpectedly. It runs as the GG core user, and the dependencies define that it can't run until after the GG config daemon service has started running. Every Nucleus Lite daemon has a socket so that the daemons can message each other to orchestrate the Greengrass functionality. We turn our attention now to the GG pub/sub socket file. This file is also part of the Greengrass Lite multi-target. The socket stream it listens to is in /run/greengrass, and the socket is owned by the GG core user. The /run/greengrass directory contains the streams for all of the Nucleus Lite daemon sockets. As you may recall, the config YAML file defined the root path as /var/lib/greengrass. This directory contains the configuration database. It also contains the inter-process communication socket used by components to communicate with Nucleus Lite and with each other. Furthermore, our YouTube demo component and the Stream Manager component have been installed here. We have the artifacts, the recipes, and the work directories. If you've examined the Greengrass Nucleus directory structure before, this Nucleus Lite structure should look very familiar. Of particular interest are the systemd service files. Both Stream Manager and YouTube Demo have a service file matching the systemd services we saw running a few moments ago. However, the YouTube Demo component has an install service file. This corresponds to the install lifecycle of the YouTube Demo component. So every lifecycle step of the recipe is installed as a systemd service. Since installation is already complete, that service is no longer running. There's no install service for the Stream Manager component because its recipe doesn't define an install lifecycle step. Inspecting the YouTube demo service file, its working directory is under /var/lib/greengrass, as we've already seen. The IPC socket is defined using the same environment variable as Greengrass Nucleus. The component is launched using the recipe runner utility we mentioned earlier. For its arguments, it takes the component name, the component version, and the lifecycle step, which is run in this case. Additionally, you can see it runs under the GG component user, and it's part of the Greengrass Lite multi-target. Looking at the install service file, it's very similar, and the recipe runner launches the install lifecycle step instead of run. As mentioned earlier, Greengrass configuration is held in an SQLite database. We can use the SQLite 3 utility to open the config.db file. Listing the tables, the database is comprised of 4 tables with the configuration keys and values in separate tables. Listing the key table, we find some keys that were in the config.yaml file, and we find the message key from the YouTube demo component configuration. Note that it's index 77. Listing the values table, we find that index 77 has a value of hello as expected. You can of course use join queries to return a key with a matching value, as shown here. The Nucleus Lite logs can be found in the systemd journal, and can be inspected using the journalctl tool. Here we list the last 500 journal entries. This interleaves messages from all systemd services running on the device, not just Nucleus Lite. Journalctl can filter by unit name, so we list the Nucleus Lite units. And as an example, filter the journalctl output for just the GG deployment daemon. We can likewise filter for the YouTube demo install service, so we can review the install lifecycle step of the component. Similarly, we can filter for the YouTube demo run service and confirm that the component is running and publishing a message every 10 seconds. Thanks for watching this video. If you have any questions, please ask at repost.aws. I may see you there.